The ExoMotus M4 is a robotic gait rehabilitation system designed for overground mobility training. It combines wearable exoskeleton support with a mobile base to assist lower limb recovery in clinical and research settings. Developed by Fourier Intelligence, the ExoMotus M4 was released in 2022 and is classified as a Class 2A medical device under European MDR. It is CE marked for clinical use across Europe and Asia. Headquarters and production are based in Shanghai, with global R&D centers in Singapore, the United Kingdom, and the United States. The system supports hip and knee flexion extension to reproduce natural lower limb motion. It facilitates neuromuscular re-education and promotes symmetrical gait patterns. Ground feedback enhances proprioception. Torque is calculated based on rotational inertia and angular acceleration. Angular velocity measures how quickly the joint angle changes over time. These biomechanical parameters contribute to improved gait efficiency, restored balance, and reduced therapist effort. ExoMotus M4 is used in neurological rehabilitation for stroke, spinal cord injury, and cerebral palsy. It supports orthopedic recovery following surgery and enhances mobility training for elderly patients. Research applications include gait dynamics and motor control studies. Deployment spans inpatient and outpatient rehab centers, neurology and orthopedic hospital units, and university labs. Primary users include licensed physical therapists, biomedical engineers, and rehabilitation specialists. The system features a modular mechanical assembly with a lightweight, energy-efficient frame. Torque-controlled motors are integrated at the hip and knee joints. Smart adaptive control enables real-time torque adjustment. The upper frame is made of carbon fiber composite. Hip and knee actuator modules generate and regulate joint torque. A lithium-ion battery powers the system, while Omni wheels on the support base enable overground mobility. The control interface includes sensors and feedback systems. Integrated sensors include inertial measurement units for tracking joint angles and angular velocity, force sensors for ground reaction and load distribution, and pressure pads for heel strike detection. The feedback loop uses sensor input to adjust actuator response. Torque output is calculated based on the difference between desired and actual joint angles and velocities. This enables adaptive assistance, real-time gait correction, and quantitative motion tracking. Adaptive torque control adjusts assistive force based on user strength and fatigue. Real-time learning continuously updates control parameters. Patient-specific calibration stores gait patterns for personalized assistance. A physical override caps torque output to maintain safety. The control cycle includes learning, adjustment, assistance, and repetition. Gait symmetry improved by 38% over 8 weeks. Walking endurance increased by 25%. Energy expenditure decreased by 30%, indicating improved movement efficiency. These metrics were tracked weekly and reflect progressive gains in rehabilitation. Compared to Locomat and ExoNR, ExoMotus M4 offers full overground portability, real-time AI feedback, full vertical degrees of freedom, individual gait learning, and minimal therapist supervision. It is CE marked and pending FDA approval. Knee torque reaches 38.6 Newton-meters with angular velocity of 2.0 radians per second. Hip torque peaks at 40 Newton-meters. Average knee torque is 35 Newton-meters. Efficiency is measured at 82%. Power output is calculated by multiplying torque and angular velocity. Total torque is modeled using rotational inertia, gravitational force, and joint angle. Routine inspection is required every 250 operating hours. Firmware recalibration occurs every 500 hours. Assembly takes less than 15 minutes and requires no tools. Steps include frame assembly, battery integration, and control unit connection. Torque and power calculations are used to verify mechanical readiness before each session. ExoMotus M4 is not FDA approved and is limited to CE-marked regions. Battery life is approximately 2 hours, requiring frequent recharging. Acquisition cost ranges from $80,000 to $100,000. Professional supervision is required for calibration and safety. The device is optimized for mid-height adult users and may not accommodate all body sizes.